So, good afternoon, my dear viewers. Now it's time to start my another stream of the way how I'm gonna work on one of Magento open source projects related to the cache functionality of Magento. So, yesterday I had a call with guys from architecture team, and they helped me to find out one of the problems with my plugin I was trying to develop for the cache model, because apparently the cache model is actually initialized before the plugin system is started. So I had to change a little bit the way how I'm gonna achieve the desired functionality, and for that purpose I'm created actually a new cache type. So far it contains some of the functionalities over here, like loading, saving, removing. It doesn't have yet cleaning, and it doesn't yet have testing. So this is what we're gonna focus on right now as an implementation. So I already started writing a test here. Let's start out here. So cleans only stale cache when all modes are specified. This is a test case I've created. So let's start it out. Here we have, let's say, this cache. This is actually the cache that Magento using. So let's take a look at the stop method. So actually bootstrapping the object managers, and I create an object called stale cache, and over here I specify which cache type I'm gonna use for storage. So I'm gonna use the same cache type as the config cache is used for this test. And then I initialize actually also the config cache instance as well, in order to validate the data is correctly saved as I expect. We also see here, for instance, that in a stale cache, in instance, when I save something, it actually adds specific formatting to the cache key. So we see, for instance, that this identifier format that is passed in the constructor here is getting applied to the input identifier. And actually, yeah, the tests are green, so it's already quite good. Then we have also a couple of other tests related to this formatter, like removing, saving, loading. So it's very basic tests. Let's see what can we achieve now. So now we need to clear only stale cache when all mode specified. So it means when we just clean a cache without any parameters specified, it just should clear only oh sorry, it should be stale. It just should clear only stale cache. Other caches should not be affected. So let's just quickly do some setup phase in our test. So stale cache, let's save some data in stale cache, right? And let's call it some data as a key identifier, and then let's have also cache, and then we have data in regular cache. So this is going to be some regular data. And now when we run a clean, I expect that after that I can just verify that let's say the item called oh, actually I can just load, I think, as well. So I can just assert that it equals, and here I'm also gonna use an array, and the first one is gonna be the one that is some data. So as we know, it has this stale and stale around the cache, the key code. So let's put it here like some data, and then let's put here stale, underscore, and here also stale underscore, so the same way how we provided this identifier format. Then this one we've done with. Then we can go on into the regular one as well, so cache load, and then it's gonna be some regular data just as it is. And what I expect that the first one will return me false because this data should be cleared from the cache, and the second one should actually return me data in a regular cache, right? Let's see. I expect that the test is gonna fail. If it's not failing, it means my test is wrong. And because it's not a unit test, as you see, it's very slow because Magento does some initialization of the application in order to test it. I have actually to do an integration test here because I'm accessing the front-end pool for this stale cache instance, and this front-end pool is quite hard to instantiate, and I don't want to create in-memory variations of this front-end pool. It just doesn't make sense. I just want to test the code, and that's all. So okay, cleans only stale cache when all modes specified. We see that nothing actually is cleaned, right? So what I can do, I can right away go on and just make sure that I can clean something with, let's say, mode and text. So let's just pass it as it is, and let's see what will happen. I think right now it's gonna just clean all the configuration cache right away, and it's still gonna fail because now both of the instances are gonna be false. Yeah, so we see that the second one is false, so as expected. Now because I have this one working like this, so first of all, like, I don't need to clean mode all. I don't need to use the clean mode all when I clean everything. So let's say I need to replace the mode then with this. Actually, it's going to be Zendcache clean matching tag. So it's going to be a condition for matching the tags of my custom cache type. Then which tags are gonna be there? Yeah, we're just gonna add our this cache tag, the ones that we pass into the constructor, and let's see what will be the result now. So right now I expect it's still not gonna work because I didn't add the cache tag anywhere where I save the data. So okay, so now we see that it's still failing because, yeah, it runs the clean, but it doesn't run it by our cache tag that we've provided because I don't save this cache tag anywhere. So here in a save method, actually what I need to do, here I need to add to the cache tags that I have for this module. So just like this, and let's see if it works. I expect it should be green now because I added all the required stuff for cleaning the data by modal. Okay, so this test case works well. Now let's say I want to add some additional logic. Here I want to add also, logic where I actually provide some custom tag. However, it shouldn't be the case for stale cache, but just in case if someone wants to provide a custom tag, I want to make sure that these custom tags are cleaned together with the stale cache, right? So what I will do, cleans cache for all cache entries matching tag combination, right? So here what I'm gonna do, I'm gonna clear by Zend cache clean matching tag. All right, and what I'm gonna specify here, I'm gonna specify some tags like tag1, and here when I'm saving the data to the stale cache, I want to add this tag1, and here I'm gonna also add the same tag again. And I also gonna add another entry into my stale cache called tag2. So in order to make sure that it only clears the data matching the tag1, and then I'm gonna add this one here. Yeah, so some data tag1 and some data tag2, right? And now let's add it here. So some data tag1, some data tag2, and here the tag1 one should be cleared, and data in stale cache tag1. Oh, actually this is tag2, right? So, and here the tag2 and tag1. Okay, so this seems correct. So here we have tag1, tag2, tag1, tag2, tag1, tag2. We're cleaning only data with tag1. So here we put an expectation that I should receive here data in stale cache 2. Okay, seems reasonable. Let's see if the test fails. I expect it to fail because I think right now I'm cleaning up everything. Oh, actually it works pretty well. So apparently I already covered all cases with this simple line of code. Okay, so the clean functionality works as expected. I'm not planning to implement matching any tag because it's also not implemented in standard Magento tag scope. If you take a look here, you can see that if it's actually it's implemented. Yeah, actually what we can do, yeah, we can just add this logic as well. So let's see how can I implement it. So now I want to make sure that either tag1 or tag2 are matching. Actually, I also want to add another test case here. I want to add a test case that cleans cache for both tags matching the entry. So I want to create a couple of tags. I want to create tag1 and tag2, and here I want to specify the tag1 and tag2 as a matching. So it's again should remove only the first record, but as we see we have here a condition like tag2, so it should work pretty well in my opinion. And this is a test case just to make sure that we are not going to break the matching end condition. So let's see. Okay, the test is green, it's good. Then we're gonna go on and implement another one, and we will call it cleans cache for any tag match. And here we're gonna keep the data the same. Probably we can actually even move this one into another method, but yeah, let's see later. Okay, here we have some regular data, tag 1, tag 2, tag 2, tag 1. Here we're gonna clear matching any tag, so this should be cleaning all the records that have tag 1 and tag 2. Even this one should be cleared, only this one should be left intact because it's not a part of the stale cache. So here we should receive false for both entries in stale cache. And let's see how it goes. Cleans cache for any tag match. Okay, failed asserting the two arrays are equal. It's our failed test case. So let's make sure that we're gonna implement it correctly now. Now we have a check here probably, and here I'm gonna test that if mode equals, let's say, then cache cleaning to match any tag, then for each tags as tag we're gonna execute this find frontend clean, and we're gonna specify here this cache tag, so our tag, and we're gonna specify the actual tag provided over there, and we're gonna specify here the mode as then cache clean mode matching tag. And here probably we're gonna also remove this variable because it's redundant. All right, and now we have a very simple logic. So if it's matching any tag, we are gonna perform for each and clean, and probably here we also need to return some result. Yeah, so what we will do, we will just accumulate the result. Result equals result and the result. Actually, probably it's not a good idea to do like this. We're just gonna put this one first and then result. So the cleaning happens anyway, no matter when it's called. Okay, so it's gonna clean the cache and then we're gonna return back the result. Let's see if it works. It takes some time to run the test. Perfect, so now we have actually almost completely functioning the cache custom cache model that will be used for our stale cache. Now let's actually I'm gonna remove this one. It's an unused use statement. Now let's go on and create another one, another test. It's here. Okay, so another test we're gonna create is gonna be about testing for cache availability. So this is another method that is still unimplemented, so we can see it here. So the test method is not yet implemented in our custom cache model. So let's create one test case. Probably it's just gonna be the same as load and save. It's just gonna test that identifier is used for finding the cache value. So uses identifier to check for cache availability here, and uses probably identifier format. This is the one provided in a constructor. So here we're gonna have to use a stale cache, and we're gonna test that let's say some data this sort, let's say some data in cache, right? Assert true, so it should return us true for testing that this data is there. And we can also here save this data first, some cached data, some data in cache. So we know that save is gonna use this identifier. Let's run it. Failed asserting that null is true. Okay, it's a good idea. So right now it's everyone turn around, because I'm gonna just return true here. It's called fake it till you make it. So now it's gonna be green, of course, because test will always return true when I call for it. So it's gonna be moving me in direction actually to evolve functionality into the full working code. Okay, here we have the passing test. Now let's create another test case, and I will call it returns false if data is not in stale cache. So what we will do, we will just assert false when this stale cache test some data not in cache, right? So this is it. Let's run a test. Okay, so it takes some time. Okay, it fails. Of course it fails, because I hard-coded the true value. So now I can actually replace this true with the actual implementation. So you might ask why I do this redundant test case. First of all, it's one of the principles of test-driven development that every single line of code in your code base must have a reason. And if I can replace the line of code with some faked value and other tests don't catch this line of code being removed, it means that this line of code doesn't have a reason to be in a system, because there was no test covering this line of code. So let's see what we have here. So format cache identifier, actually not load but test, right? And here we're gonna have our identifier being passed. So format cache identifier, it's already a refactored method, because before I was just using directly printf. Let's take a look. So if it goes green, it's very good, because it means that I can go on and implement something. Wow, what is this? Oh my goodness. A very interesting unexpected behavior. I've never seen this one before. So what does it return? Oh, so it returns last modified time of cache entry if it's available. Okay, so it's not exactly what I expected it to be, because like test, yeah, what is test? Yeah, like, okay, so assert then not equals because I cannot test exactly the time when cache was modified, so I can just test that it's not equals false. So stupid test case, but yeah, it's a little bit unexpected behavior. Okay, so now it all passes. Okay, good. Now we have a working stale cache. So let's see what we can do with this one. So now I'm gonna go into the glorified Magento cache, Magento config module. Sorry, this is the one where the system configuration resides. And here in DI, I want to specify the same thing as it was there before. Like for system cache, it takes as dependencies this configuration object. Let's see, where is it? Let's look for system slash backslash, yeah, here I think it is. No, it's not it. System, okay, so Magento config app config type system. So this is one. So here we see that the cache instance here is passed directly as this one, and this is what actually I'm gonna replace with the virtual type. So what I'm planning to do here, I'm planning to use another class I've created called state cache replica. This is kind of a class that already implements the functionality of loading the data from slave that will be our stale cache storage when the master cache is locked. So what happens here, we can take a look at this functionality here. For instance, that let's say we have this cache data being loaded from master cache. If the data is not available there, then it takes a look at if the data is locked in a master cache. If it's not locked, what we do, we actually load the data from slave. Actually, if it's locked, then we load the data from slave. Otherwise, we just return false because the data is not available, so the cache needs to be generated. So it's the basic idea of this replication-based cache storage. Actually, I found out that I'm missing actually here one test case, I think, right? So I'm missing here a test case for test as well. So let's take a look. Let's see. How do I navigate to the test case? I think this one, yeah. So let's add another test here. This is what I missed when I was working on it. Let's add a test case. Returns true when cache entry is available in master. So here I'm just gonna set that the master cache, let's say, has some data in it, like data in master, and we'll call it master data. And here I'm gonna tell that our cache model tests for this master data and returns true. So it returns true when the data is available in master, and I expect that this test actually going to be red, right? So it's red and it's good. And this one, as you see, is very fast to run because it's a unit test, not an integration test. It doesn't require to bootstrap the whole application in order to run a test. So here we have assert true for testing availability of this cache entry. So again, everyone turn around, because I'm just gonna return true here. Okay, it's green. I go to another test case. Let's say returns false when cache entry is not in master, even if it is in slave. So this is a basic idea. So if you want to test existence of the cache entry, it should return you false because it's not in master. Even if we have the data in slave, we don't want to break logic unrelated to our system config config model, because there might be some other calls to test that we are not aware of. But as far as I know, the system model doesn't do any calls. We just want to make sure that it only uses master as a main check for availability of the cache. So let's assert that it returns false for this cache test. Slave. Oh, actually, master data, and here we're gonna put this data into the slave cache. So in the end, yeah, it returns true because I hard-coded it, and here, yeah, just let's make it easy to understand that this one is stored in a slave cache, so data in slave, and then we return false here. So what I can do here, I can just replace this call with master cache test, and then I specify the identifier that is passed into the master cache. Now let's see. Okay, the test cases are green. So now I can use this one finally and replace the code here. Here, as you remember, in our system, we were using a very custom way of loading the stale data. I'm just gonna actually remove those methods because they are completely redundant in this implementation now. So load default scope data as well. The stale data is going to be removed as a method call. Also, the same thing is going to be removed for this one as well. So there's no need to load all stale data from cache either, because all the data is going to be replicated into the stale cache instance, and then internally it would just use this composite cache model that will decide based on the locked status of the cache type if it's gonna do something about it. And here we actually also gonna remove this call to save the stale data, right? And here actually we're gonna also just inline the call to that method like this, right? And here we're gonna inline also variable because it's redundant here now. What else? We're gonna change here. I think there was some method that I don't call anymore. It's called load stale data or something like this. Private, yeah, load all stale data from cache. This one is not needed as well as this constant I was using for the stale cache key because it's not gonna be used anymore. Okay, this looks good. Now let's switch to our test case. Where is it? Here it is. And let's actually run this test case. Oh yeah, I have to configure it in PHP-storm to replace unit with integration and remove dist in the end. Okay, let's run it. Let's see if we broke something. Okay, the first test case passes. Second test case passes. Third test case passes. It's already a good sign. Okay, so this one is broken because yeah, I know why it's broken. So test cleaning website cache and looking at returns stale cached value because we don't have any stale cached value. Well, let's see if we can actually fix it without introducing the stale cache, because it's also a test case for data retrieval directly as well. So let's see system, and can we actually see about the data read. So we have load default scope data, then it reads the data, and it's then caches the data. Okay, so here we have also the read data, then we have the data cache. Okay, actually this one I can already simplify in my opinion, because it's a little bit complex, I think. So this one, when we return back the cache data, the data might be in different format when it's saved. So yeah, it's a little bit strange implementations that I was fixing before, because you remember it was returning scope type as an array and so on. So what I want to do now, actually, I'm gonna make sure that, let's say here, when I access uncached data, I can somehow process it. So let's see, can we do something about it? So we have read data, then this data gets passed here. It's one thing, but what if I want to make sure that the data that I receive from for the default scope is always related to the default one? So let's see what we have here. Read data, it gets invoked, it takes the data that is directly returned by Magento data reader. So we have here the data saver that's invoked on the data that is cached. However, the problem is that this data saver contains some logic in order to process the data before it's saved. So maybe we can change a little bit the implementation here, and let's say for the lock guarded cache load we can replace functionality that would allow us to format the data after it was retrieved directly from the data collector, but the data was, let's say, not formatted. So let's see. Non-blocking loader allows to specify stale content loader. So this is something that we've added, but we don't want to have a stale data loader. We want to have actually the data formatter. So what we actually want to do in the end, we want to just format the data that is going to be returned back. Either it's cached or uncached. So we're going to actually separate it into a separate callable, and it's actually going to be pretty cool in my opinion, because then I can simplify the code in systemxml. So let's see, return past data with merged value. So okay, this is cool. Then we have this one happening, right? And then we just want to apply some processing over here, right? We just want to add something like process the data. Okay, so let's actually get rid of these two test cases because they're completely irrelevant for us. Right, so what we're gonna do, actually, we're gonna rename this one. We're gonna rename it non-blocking loader allows to specify data formatter for locked. Oh, actually, let's put it this way. Data formatter gets invoked on non-saved cache scenario, cache flow. Okay, this is works well. So we locked our lock. Then we return that there is no data in cache. Then we return uncached data, and then what we put here, we return the past data with merged values. So we expect that, let's say on a save scenario, so this is our save handler, we're gonna put something like saved to the, we're gonna add it the merged value, and then we're gonna add another one here, and we will call it formatted. So in the end, what I expect that it will go through uncached. So first we receive the uncached data, then it should apply return past data with merged value. So then it's gonna actually not use saved, it's gonna use formatted, because the saved stage should be skipped when we having the cache being locked. So let's see what will happen. Oh, actually, I was supposed to run a different test case. Let's see. Too few arguments to function. On line 128, exactly one expected. What? Too few? Too many, right? Oh yeah, I see what's the problem. The problem is actually in implementation of this log guard. So here it's gonna be called data formatter, and it's gonna be optional. So if there is nothing to format, we don't need to specify it. So this data formatter, yeah, so this stale log actually is not gonna be invoked at all. We're gonna use data collector, and here we're gonna use our data saver. Then we're gonna apply this data formatter on top of it. Yeah, sorry, I need to turn this off. How do I switch it? Oh yeah, do not disturb. So this one, data formatter, cache data, data formatter, then data saver. So it will format the data returned by data saver as a cache data. Or actually what we can do here, actually we can bypass this one, and let's say if cache data, then we apply the cached formatter on top of it. Otherwise we just return back the cache data, right? Oh yeah, and apart from that, it's actually gonna be a cache data, I think, like this. Probably no, it should be just returned like this, because if we have nothing returned from data collector, it just should be not returned. So let's see. Okay, it actually passed as a green test, and let's run all other tests. So a function name must be okay. Non-blocking loader returns uncached data when nothing is retrieved. Okay, why it's... Oh, okay, because it should be data formatter. If there's data formatter, then we apply data formatter on top. Otherwise, we just return back the cached data as is. So let's see. Yeah, now it looks better. False does not match expected type array. Where it is okay, because non-blocking loader uses uncached data when stale cache loader returns false. Okay, this is clear, because this is actually not going to be a test case anymore. We don't have anymore the stale loader inside of the log guard. Okay, let's see. Okay, now it's all green, and now I can actually simplify the logic inside of the system.php. So here you remember we actually were returning something like this. So we were putting logic like that one, and now we will just return here data, and here we will actually, let's fix this one, let's put it back, and then here we're just gonna add another function called data formatter. It also receives data. This one actually will use scope type, and it's gonna returning the data from scope, and here we're just gonna return back data. Actually what we can do, we can actually replace this one with closure from callable this cache data, right? So we're just gonna make sure that it's just gonna cache the data. Do cache data return us something? No, let's just return this data back, and it should return back an array. So we change the behavior of this method. Okay, so data gets stored like this, and it's going to be returned back. Now we can apply the same logic here as well. So here we're gonna put also from callable also cache data, and here we just gonna put it like this. So it's also gonna be well working in my opinion. The only thing where we'll have stuff left to do is here. I think here we just can again do the same thing, cache data, and we can just remove this call, right? So let's see if our system test is still gonna pass. Okay, tests look green so far. Let's see how it goes further on. Please make all the integration tests green. Then I can go on and replace dependency in DI, and then we call it an end of the implementation, and then I can actually run some load tests. Okay, it's perfect, it works, and it actually looks a little bit better now, but yeah, I still don't like this piece of code, but yeah, it's just to preserve the functionality how it works right now. Let's go further. Let's see. So here we have everything I think is done here. Yeah, there's nothing left from the previous implementation. So now I can just go and change DI. So here we're gonna replace this Magento framework app cache type config being passed inside of the system config. We're gonna create a new type called, actually virtual type called system config cache replica. It's gonna be based off type cache replica, where it's here, stale cache replica. Probably we can also put here stale cache replica as a part of the name. Then we're gonna pass some arguments inside of this one, and the first argument is gonna be why it doesn't auto complete it? It's strange. Okay, so the first argument should be master cache, then slave cache, then lock manager. Okay, the lock manager is actually something that we don't have to specify ourselves, or maybe we have. I will check what's current configuration in DI for the code. So let's first start with master cache. Okay, so master cache is gonna be XSI type object. It's gonna be our main cache type, this one, right? Then we're gonna have another one, and it's gonna be our slave cache, and it's gonna be XSI type. And for this one, it's also going to be an object, but for this one we actually have to create another virtual type, because I have to configure this one. We will call it stale cache type. We'll call it like this, and then it's gonna receive as an argument the frontend pool. Yeah, it's okay, but then I need to specify the cache. Oh, it's actually, I need to specify type here first. Stale cache type. It's gonna be cache type. Then it's gonna be XSI type const. And here I can use the constant from the type config, and it's gonna be the constant called the type identifier, so the same one as in our configuration cache. Then we are gonna have the cache tag, and this one is gonna be XSI type const. Actually, not const, because we don't have a constant for that one anywhere in the system. We'll just make it string, I think, and it will be a stale cache. Okay, what else do we have in this class as an argument? Also identifier format. I think it's important as well. Right, so identifier format is gonna be argument name identifier format, XSI type string. It's gonna be stale, then config, then string, and then let's add something like stale in the end as well. So it's gonna be surrounded by this one, so it's gonna be hard to collide this name. Stale config, and then the name of the identifier, and then the stale as the suffix. So yeah, oh, where it was, yeah, here it is. Okay, stale. And what else do I need to specify as an argument? Do I have anything left? Cache frontend pool, it's already there, I think. Yeah, I think nothing else. Let's just verify it in the class constructor. Cache type, identifier format, cache tag. Yeah, all the required string arguments are provided. The frontend pool is going to be provided by Magento automatically. I don't need to specify that one. And here I'm going to specify this stale cache as a slave cache for our cache replica. And here we're going to also provide a very specific argument with a name. I think it's called master only identifier. So this is going to be a XSI type array, and here's going to be item, and the name of the item is going to be, yeah, it doesn't matter what's the name, but it's going to be scopes for just understanding what it's about. Then XSI type is going to be I think const, and it's going to be related to the functionality that Magento has here. It has a functionality called list of scopes which are stored as a separate cache entry. So get all available data scopes, and you see here it's actually specified like this. So it's config type, and then it's actually scopes, right? Okay, so yeah, I have to actually hardcode it in DI.XML because it's impossible to move it as a constant, so probably I have just specified it like string. So let's see what we have as a cache type for a system. So the cache type we have actually, yeah, the config type, it's system. Okay. This one is gonna be put here inside of the scopes. So system, and then we will specify scopes. So this is a suffix that is used in Magento implementation. So scopes, yeah. So here's the suffix. So we're gonna go back into our DI file. Everything looks good here, right? Then what else do I need to specify for this cache replica? Lock ID. So the lock ID is quite important. Again, Magento doesn't make it simple because this one is actually provided as a string literal, but I can actually extract it as a constant, and I will call it lock name. So it's just to use it internally much more easily. And here we will say that this is our lock name for the cache. Lock manager. Okay, so it's gonna be called name of the lock to acquire during write. Right? Looks okay. Acquire. So it's gonna be a const, and here I'm gonna specify it as well as a constant. So argument lock ID XSI type const, and it's gonna be system config type system, and then it's gonna be lock name. Yeah, this is gonna be our lock ID. Then I don't remember, do we have some kind of lock query configuration? Okay, so the locker is this one. Okay, so this is actually our lock manager that is used. So okay, we're gonna reuse the same type to make sure that everything is working correctly. So here we're gonna specify argument name lock manager XSI type object. Okay, so it's our virtual type for system config stale cache replica, and now we finally can replace this as a dependency. And let's see if the system cache still works after our dependency being replaced. Let's wait for it. It's probably now regenerates some of the NDI configuration. Okay, something is already good. It's already was able to instantiate the test at least. The first test passed. The second test passed. The third test passed. The fourth test passed. The fifth test pass. The sixth test passed. The seventh. The number 8. There is 2 more tests to go. 2 more. Let's see how it goes. Okay, so all tests are green. All tests are green, and I'm super happy because now I can just commit it. Perfect. Perfect. Add dev tests. Git add lib internal. A lot of stuff I've added to the framework. Git add this one too. So config module changes, and let's see. Do I have everything? Yeah, this one, this one, this one, and this one. Git commit. Complete implementation of a stale cache reader, sorry, read during lock on write. So can we call it an end? So let me go into an amazing node that was actually provided by Mojostratus. Oh, come on. I did forget to add my Office IP address into Mojostratus. Let's go. Mojostratus. I think I need to go into their panel. Mojostratus. Okay. Where is the link to login? Here it is. Okay, let's use my amazing LastPass. No one knows my password, so it's good. Now let's go into my servers. This is very nice server. Ew, I don't have any service provisioned yet. What? My Stratus maybe? Oh yes, so it's my what? Stratus control panel. This is it, I think. Yeah. Let's run it. I think this is my Stratus instance. Yeah, correct. Let's go into users and let's just actually whitelist. And here I'm gonna add my IP address, and I'm gonna just specify it's my office. Okay, create. Let's see if I can log in. Okay, it takes some time. Let's see. Let's log in. Yeah, perfect. I'm in. Oh yeah, definitely. I need to forward my SSH keys. Setting public, get pull. Did I actually push? Yeah, I did push. Let's see. Okay, everything is pushed. Now what I need to do, I need actually to execute this command I have here. I created an SH script called flash. So first, yeah, let's flash this to this repository. Let's flashing cache and sessions. Also, I think like I need to execute, I think bin magenta setup di compile, right? Because I've changed some of the settings in DI, so I need to recompile the DI configuration just to make sure we don't have anything wrong with that one. Okay, this one is done. Now let's, oh, actually, let's not do that one yet. Let's not forget that we need to deploy the code across all of the nodes. Now I can, after it's done, I can run the flash, because then it will perform the cache for our test case. Let me open another window and log in into this nice server. Okay, is it the one with fix? Yes. Okay. Okay, the code is deployed. Let's run this one. Oh, it's closed. Oh, because probably they restarted some of the instances. Okay. Let's see why I can't log in. What's up? Why I can't log in into this node? I have internet here, right? So it shouldn't be a problem. Okay, can I at least access a node? Let's try to see. So this is, I think, the one with direct access to the configuration. So yeah, it's our standard Magento sample data. Okay, we'll figure it out later. Let's just start hammering it, and let's just take a look at the results right away. M2 test result. Let's log in into my Grafana instance. Let's open our fix one. Let's see how it goes. So we have maximum 20 active users right now. Let's put some condition here. Now and refresh every 5 seconds. So okay, here is a test cache flash. It looks actually pretty good. The cache was flashed, and during this cache flash, let's see, it happened here, and nothing was above the value that we have set. So here I expect there was some lag on the server, because it doesn't seem related at all to stuff there. So yeah, it looks very smooth in my opinion. So 75 requests per second, not bad. Let's see. Yeah, I like this line, because the previous ones was looking not as good. So now I see a very smooth process going on here. So you flash the cache. It has some spike at, yeah, let's see, this is the cache flash. What happens here? The load times, yeah, still below 1 second. It's, I think, pretty good. I think we can even hammer it with more load. Let's see. Come on, why it's doing stuff like this? Is it because of my... Yeah, it's because of my screen length. So yeah, let's restart this one and let's actually do something related to the actual develop instance. Let's deploy stuff that is available in Magento Core. Let's do some switch of the branch. Let's switch to git checkout develop. Actually 2.3 develop. So it's a standard implementation. Let's run this bin Magento setup di compile, right? So we have a proper version of the compiled data, right? So we don't have any side effects related to our code being there. Okay, so it's almost done. Right, here we go. Let's go on and let's run this flash. Oh no, not yet. I don't need to yet prewarm. I need to deploy the code first. I always forgot about it. Let's see if our deploy is going to be fast or not. I hope it's going to be fast. Okay, it will show us. Will it complete the deployment or not? Hope I don't need to relog in. Oh yeah, so it's a sign that the deployment is complete. Let's try to log in back. Okay. Why I can't log in? Come on, guys. Let's do it. Okay, let's just take a look if everything is working. Okay, I can log in here. I can go into tops category, checkouts maybe. Wow, there's no products. Why there's no products? It's interesting. Okay. Can I log in? Yeah. Let's check why it's not showing products. Maybe I need to run bin Magento indexer or index, sorry. Indexer or index. maybe I have to redeploy the sample data. Okay, so sample data reset. Oh, sorry, Magento sample data reset. And let's run setup upgrade. Where are the products? There were some products before. Where are you, products? Where are you, products? Okay. Bags works. Fitness equipment works. Okay. Pants. It's empty. Jackets. Yeah. Okay. Let's put some category with bags as part of our test scenario, because yeah, this was part of scenario in run. So admin.js. Let's take a look at our test case here. So we have this category page with products, and the category page woman works pretty well. So then we're flashing the cache, we visit pages. Okay, looks great in my opinion. Now let's go here and let's actually, oh sorry, let's redeploy. Sorry, it should be I think be in Magento setup di compile. Okay, this here. Now let's also set up static content deploy. So I think we should be done here. Now let's log out of SSH server, I think, after this one is done. So exit. And now let's deploy the code. Now here we're gonna switch into another InfluxDB, into which I'm gonna write the test results. Let's see, it's still deploying. Okay. Let's see how it's going. Okay, the data is redeployed. So now I actually can just visit this page just to check that the cache is pre-generated, right? So when it's gonna be there. Okay, what happened? Did I break something? Oh no, it takes some time to get it back. Okay, then let's go into the woman category. Okay, it's just a category with some static blocks. So yeah, let's go also visit the home page. So it's gonna be a complete warm-up. It's all the pages I'm gonna test. Let's go on now and start testing it. Let's see. This is interesting. Let's see what it will show us. What? Why it's going into 2 seconds? Oh, okay. So here's the issue with the current implementation. As we see, there are some spikes. So we cleared the cache and there are spikes in the load time because all the processes started to wait. Okay, let's go further on. Yeah, here there was no coincidence in this run, but then it's gradually increased for some of the cases. Okay, we see it's actually coincides with this one a little bit. Okay, I think it's good improvement, because if we take a look at the fixed version, we can see that yeah, there were some spikes, but they were not about 1 second, so it's actually, and they were not too long, so then it went all to normal. So there were some percentile of this request, so it was much more smoother. And let's take a look at the current. Yeah, it goes about 1 second, and yeah, average number of requests per second is 60, and over there it was last 30 minutes. What? It can be so much. Okay, so this sounds much more better. 82 maximum and 69 as average. So I think it's not a bad improvement. Like, don't have much more requests per second. I think it's, so if we put something this area. So it's 62 and 75 max, and there's 69 and 82 max. So not bad. Yeah, at least it showed some improvement. Couple of additional users was able to buy, would be able to buy products just by these optimizations. Okay, and let's see again here. So yeah, it's much better in my opinion. Look, the cache flash event takes 200 and 114, and here it's a little bit inconvenient in Grafana. And here 130, 165. Yeah, so cache flash is taking the same time. However, yeah, it's not consistent, I would say, from performance perspective. As you see, the graph looks like this, but we will restart the load test also for a fixed version. But as far as I see, at the moment, even with 20 concurrent users, the current implementation is not very good for performance, in my opinion. Okay, is it finished? Almost finished with this develop test. Okay, let's switch to our branch with our fix. Okay guys, so I think I'm gonna finish a stream here, and it was nice working on this small project. I think I'm gonna run a couple more load tests to see how it works and how it performs under higher load, and then it will be posted together with the updated pull request to Magento. So hope everyone can benefit it soon in a newer released version. So bye bye.